I know you might be at some different spots, but we'll just kind of pause here, step back a little bit. I'm going to show you some steps. If it helps you to write them down, if it doesn't help, just read them. But you do kind of follow these steps every time. You let u equal the inside of the function. You let u equal g of x. Again, let u equal the inside of the function. You'll always do the derivative of u. You'll always do that little sidebar of calculus. So you're going to do the derivative. Now it says here that sometimes it's helpful to rewrite that equal to dx. So far, that's what I've done for every problem. I have solved it for dx. You will find out why I say sometimes, because there'll be some times where you might not need to do that. But the bottom line is you're going to find or let u, and then you're going to find du. You're going to do the derivative. You're going to substitute them back in. You're going to substitute them back in. Stuff should cancel. In fact, x's should cancel. And if they do cancel, then you have figured out what I call the cancellation connection. Okay, and now you should have like a simpler function. You should have a simpler function. Now, just so you kind of know when I say it again, that you realize, because it's something people forget, these three steps, there has been no antiderivative yet. That's fine. You should not have done the antiderivative yet, but you have to finish the problem with the antiderivative. The reason you did these three steps is so you can actually integrate. So you can actually do the antiderivative. And trust me, we'll be at a point in some problems that are so tricky that you'll feel like you already did all the work. But we'll go back to this and we'll say, remember, you got to do step 4. You got to integrate. Let's do just one more problem today. I definitely want you to feel like you're starting to catch on, but I also want you to be exposed to a problem that doesn't seem to kind of fit just so perfectly this idea of an inside and outside. And yet, I hope you realize it still does. It still has an inside and outside. So I got the integral of 4x over x squared plus 2. Okay, now I'm going to do something here that for some of you, you're like ready for this. You might not realize you're ready. Some of you might not realize though why I'm doing it, but in a day or so, you'll come back like, I know why you did that. But I want to take you through a little bit of a what if. What if we choose u to be? In other words, what the heck is the inside of this? You know, it's got a numerator and a denominator, so which one's the inside? Don't write this down yet. Just watch. Okay, because if I let u equal 4x, okay, if I let u equal 4x, then the derivative of u, I'm going to say, is just 4 dx, but it's just 4. Now, this is going to become u, but that means that this is what we call the rest of the problem. Now, that x squared plus 2, whether you realize or not, it needs to cancel down the road. But the problem is that down the road, the only thing I'm going to have available to cancel is like this 4. And even if, again, you're not completely sure, you have to say, well, how in the heck is an x squared plus 2 going to cancel with a 4? It's not. It's not because we did not choose the correct u. We did not choose the correct u that has the correct du that'll cancel with this. Okay, now, what if you do it the other way? What if you let u, and this is the right way, so if you want to write it down because that helps you, then I would encourage you to write it down now. What if you let u equal x squared plus 2? Listen, this is the thing. I don't want you to worry about it, but soon you're going to get this. What are you going to get? You're going to get that the derivative of u is supposed to cancel with the rest of the problem. Now, the derivative of u, let's just get it right. It's 2x dx. If I let x squared plus 2 be u, that means this is the rest of the problem. Okay, that means the numerator is the rest of the problem. Down the road, I want this to cancel. And what I really want to cancel is the x. You guys will learn that the numbers don't actually matter. Numbers can change. I erased some of it, but we had 1 over 18. That's fine. But this x is what's got to cancel. Well, guess what? It's going to cancel nicely because the derivative of u gave us or created an x. Okay, when I say x, I mean x to the first power. Let's see the cancellation. Let's sort of watch this happen. At this point, I'm still going to kind of follow what we've done a couple times. Maybe, just maybe, you're saying, yes, I realize why you're doing that, because, well, when it's 1 over 2x, then it's going to be able to cancel with this 4x. Okay, that's technically why it cancels, because now I'm dividing by this 2x. I wonder if you want to substitute. Do you want to think about it before I write it down? You should feel like these 2 yellow boxes are being substituted. You really don't have to think too much right now. You can just follow the sort of the process. Now, that means that this 4x, nothing changes, but it does mean that the bottom becomes just u. I know it seems kind of strange, but yep, it's just u. This dx becomes this 1 over 2x du. Okay, again, this is the point, and once you get this, you'll realize that x was there to cancel. That's the point where we understand really why the substitution method works. So x is gone, bye-bye x, 4 over 2. Okay, 4 over 2 is 2. 2 over u, 2 over u du. I'm not going to call on anybody, but you guys realize that you should know how to do this antiderivative. It can look a little different because it's got the letter u. It also can look a little different because, honestly, it's actually so simple. Again, don't get anxious. I'm not going to call on you, but do you know how to do 2 over u? Do you know how to do 1 over u? See what I did with the 2? You can kind of do that mentally. Good. Now, 2 ln of u. I'm being kind of technical here. It's 2 ln of u until or before I actually do the final substitution. Now, there might be some of you, again, sooner than later, you're going to be like, wait a minute, I don't really need to write u. Yep, you don't really need to write u. You could say, isn't u just going to be x squared plus 2? I don't want to get ahead of us, but I'm just sharing, when you're ready to do that, you don't need my permission. You can. Is that what you were going to ask?
Yeah.
You just did the chain rule backwards. If you do the chain rule forwards, you would do the derivative of this, and you would see that it's going to turn into that. Okay, but we just did the chain rule backwards. It's called substitution. I kind of want to start with this tomorrow, but that means I can still show it to you today. When you get this, you're going to understand that you always choose u, so that du cancels with the rest of the problem. You'll realize that you can do the substitution steps 1, 2, 3, 4, but it's about choosing u. And I want to keep helping you understand this so that du will cancel. Okay, let's look at, just to be honest with you, today is a little bit more of, here, I need to show you some stuff so you start to realize what you can do. Let's look at another fraction. The way I wrote it on the board is the way that it's commonly presented in a textbook or even a test or quiz, dx over 1 plus 9x squared. But the real truth here is that it's a darn fraction. Okay, this is going to be something you guys are going to have to work out. Let me do one thing that sometimes just makes it a little easier to look at. You say, why didn't you just write it that way the first time? Again, I wanted you to see it as the textbook or a test or quiz might have it printed. That makes it a little easier for me to say 1 over 1 plus 9x squared. Let me say that again, 1 over 1 plus 9x squared. Now, if you're saying, should I know what that is? Well, I'll say that as given, it's not, you shouldn't know, but it should kind of feel like something. It should kind of feel like 1 over 1 plus something squared. Now, what's 1 over 1 plus something squared? These guys typically answer this, but again, everybody should know 1 over 1 plus something squared is inverse tangent. Now, if you're a little bit like, I don't see it, we want this fraction to turn into 1 over 1 plus something squared. And I hope that you're looking at that and saying, oh, okay, well, there's a something. You know, what squared is equivalent to 9x squared? What's squared? It would be 3x. This is definitely a special problem. It's special because you have to realize that you need to think of it as 1 over 1 plus something squared. But as soon as I do that, I get myself with an inside function. Okay, this is an inside function. It's u. Try not to sit there and say, well, I don't know if I would have known that. You might not have known it. That's why I'm trying to introduce you to this thinking for a fraction. But look, you can do the method. The method is to do the derivative. Okay, don't worry. You always do the derivative of, in this case, of 3x. It's just 3 dx, 3 dx. Now I know I did like a little bit of a sly substitution over here, but we don't have like a lot of junk in this problem. We don't need to worry about only doing a little bit of this step. The only thing to do is to move the 3 you want to isolate dx. You want it to be such that you can say that 1/3 du is the same as dx. You want to say what dx is. I'm going to stop there because, well, I'm wondering if you guys can substitute. What I wrote down certainly has to come along. So nothing's substituted yet. Can you figure out what it looks like with substitution? How'd you do? It's 1/1 plus u squared. I hope that step that you're not overthinking, that's the essence. You have changed 3x to be u. Are you getting this? This is important. You have to realize that both of those, 1/3 du, both of those are equivalent to dx. Now, this is usually the spot where kids are at different places. Some are ready for the final answer. Some, it would help if they would see me write this. So I'm going to write it. 1/3 is just a coefficient. It's important, but it's not really part of the antiderivative. In other words, 1/1 plus u squared. Now that is the function I need to do the antiderivative. We're at that step. Can you take what Aaron said? He said inverse tangent. You know, what does that mean? Don't forget about the 1/3. You don't really have to do anything with it, but it comes down, it's part of the final answer. And now you do the antiderivative. Folks, the antiderivative of 1/1 plus u squared. Inverse tangent. Now, it's the inverse tangent of something. Technically, I should write the letter u, but I think we're ready to say, yeah, it's just going to then substitute back to be 3x. So it's the inverse tangent of 3x. Can we just go right to that final answer? I think we can. We get 1/3 inverse tangent of 3x plus c.